is a chapter I wrote with Deborah Fields, and it kind of summarizes our experiences. How do we actually teach algorithm, data structure, and all these things which are mentioned in the book within a classroom project? So, and what we put into the chapter are principles which we had learned by putting the electronic textiles into a curriculum for the Exploring Computer Science yearly plan. And we distilled this in 6 principles. One of them is promoting creativity within constraints, and that connects nicely back to Miles Berry's presentation on creative coding. So how do you actually kind of get kids to have some degrees of freedom on what they program, but also cover important concepts. So we have some ideas on how you can kind of manage to do those 2 things. A second principle which we developed was growing complexity in a series of projects, and you see some examples to the left on the screen. So starting with the most complex activity actually doesn't work very well, because the students in particular in physical computing like electronic textiles, but also other areas, actually need some experience in understanding circuits, in learning how to craft and sew. So we learned the hard way that the most difficult project needs to come at the end, and that we needed to kind of scaffold the activities in a series of projects which get increasingly more complex, so that students at the end can successfully deal with more complex projects. And the third principle is equally important. It means starting with aesthetic first. Often in computer science, we're so driven to get students to understand complex concepts, but we actually suggest that if you want students to work on projects of their ideas, to start with the aesthetics first and then worry about technical aspects, the concepts later on. Because if you do it the other way, kids kind of get stuck and don't really think about what they're interested in. A fourth point is about celebrating mistakes. Yes, programming mistakes, debugging happens all the time. And rather than to see them as a stumbling block, we suggest to have a hall of errors, of actually having students share the problems they have, as also the solutions they have come up with. In most beginners projects, students have maybe, a few experiences of bugs, but by opening it up to the whole class, they get a wider range of experiences of what other problems and solutions students have come up with. Keeping track of progress is equally important. And then finally, reflecting as computational communication, we also build in portfolios where students also keep track of their projects and then reflect on the things they designed and built. Finally, if you want to find an example, so the Stitching the Loop curriculum for electronic textiles is available online, where you can see how we actually designed the whole curriculum, the different rubrics, assessments, and activities. There are videos. And also we have create expansion unit. We work with different Arduino platforms. So you have multiple examples of how you can actually make that work. Thank you.